Python functions. Function. A function is a block of code which only runs when it is called. We can pass data, known as parameters, into a function. A function can return data as a result. Creating a function. In Python, a function is defined using the def keyword. So example, def my function, then print hello from a function. Calling a function. To call a function, use the function name followed by parentheses. So let's say, for example, in this case, we have defined my function, and then the function contains this code, hello from a function. So to call this function in your code, you just type the name with parentheses. So when this is executed, it will display hello from a function. So that's how you call a function in Python. Arguments. Information can be passed into functions as arguments. Arguments are specified after the function name inside the parentheses. You can add as many arguments as you want. Just separate them with a comma. The following example has a function with one argument, fname. When the function is called, we pass along the first name, which is used inside the function to print the full name. So define my function, and then we have the argument fname. So print fname plus and then refsness. It says here refsness. So that might be the last name. Okay, so my function Emil, my function Tobias, my function Linus. So we have Emil refsness, Tobias refsness, and Linus refsness. Okay, so that will be the output. We have called this function 3 times, and we have passed this argument, this value to this argument here. Parameters or arguments. The term parameters and argument can be used for the same thing, information that are passed into a function. From a function's perspective, a parameter is the variable listed inside the parentheses in the function definition. So that's the variable. An argument is the value that is sent to the function when it is called. So in this case, this is the parameter and these are the arguments according to this slide, but you can just ignore that one if you want to. By default, a function must be called with the correct number of arguments, meaning that if your function expects 2 arguments, you have to call the function with 2 arguments, not more, not less. So this function expects 2 arguments and gets 2 arguments. So define my function. So we have the parameters fname and lname. So print fname plus and then space plus lname. So my function Emil refsness, so it will now print Emil refsness because with space in between because of this one. So we have here 2 arguments because we have 2 parameters here. If you try to call a function with 1 or 3 arguments, you will get an error. So let's say, for example, we have the same program a while ago. So we have 2 parameters here. So it will be expecting 2 arguments, but you use only 1 argument. So it will cause an error. Okay, so more or less the output will be something like this. So missing 1 required positional argument. So that's the message, the error message. Arbitrary arguments. So we have asterisk args. If you do not know how many arguments that will be passed into your function, add asterisk before the parameter name in the function definition. This way, the function will receive a tuple of arguments, so it's a tuple, and can access the items accordingly. So if the number of arguments is unknown, add an asterisk before the parameter name. So in this example, we have here defined my kids asterisk kids. So that means we don't know the number of parameters or arguments. So print the youngest child is kids 2. Then we have here my function Emil, Tobias, and Linus. So it will these parameters will pass here, and it will only print kids 2. So 0, 1, 2. So that will print Linus. So the youngest child is Linus. So arbitrary arguments are often shortened to args in Python documentation. So if you see this one, that's the arbitrary arguments. Keyword arguments. You can also send arguments with the key equals value syntax. This way, the order of the arguments does not matter. So let's say, for example, here we have defined my function child3, child2, child1. So these are the parameters, and the youngest child is child3. So my function child1 equals Emil. So here we have a key equals value. Key child2 equals to bias equals value. Then child3 we have the key equals values. So although here child3 is the first parameter, but since in this case we have specified the key, then we can place Linus as a third argument. So the youngest child is Linus. So the praise keyword arguments are often shortened as kwargs, kwargs in Python documentation. So take note of that just in case you're going to be able to open some Python documentation. So kwargs refers to keyword arguments. Arbitrary keyword arguments, or asterisk kwargs. If you do not know how many keyword arguments that will be passed into your function, add 2 asterisks before the parameter name in the function definition. So this way, the function will receive a dictionary of arguments. So it's a dictionary of arguments and can access the items accordingly. So here we have define my function. So double asterisk kid. So print his last name is kid L name. Okay, so that means we're going to use last name for the kid. So my function f name equals to bias, L name equals refsness. But so this one will use last name. So his last name is refsness. So arbitrary keywords are often shortened to double asterisk kwargs in Python documentation. Default parameter value. The following example shows how to use a default parameter value. If we call the function without argument, it uses the default value. So we have here define my function country equals Norway. So this is the parameter, and Norway here is the default value. So print I am from and then the country. So let's say in this example my function Sweden, so we have specified the argument for this parameter. So this will print I am from Sweden, and the same is true with this. I am my function India, so it will print I am from and then the country India. But here in this example here, we did not place any argument, so there will be no value for this parameter. But since we have a default value, then it will use Norway. That's why it will print here I am from Norway. And then here of course my function Brazil, so I am from Brazil, so this will print of course I am from Brazil. Passing a list as an argument. You can send any data type of argument to a function, string, number, list, dictionary, etc. And it will be treated as the same data type inside the function. For example, if you send a list as an argument, it will still be a list when it reaches the function. So define my function food. For x in food, print x. So fruits equals apple, banana, cherry. My function fruits, so this is a list, we are passing a list, so it will print the items in our list. So my function fruits will display apple, banana, and cherry. Return values. To let the function return a value, use the return statement. So define my function x, return 5 times x, for example. So that's our function. So this is the return value. So let's say we have print my function 3. So that's 3 times 5, 15. So it will print 15. Print my function 5. So that's 5 times 5. So that will print 45. Print my function 9. So that's 9 times 5. So it returns 45. And this statement prints 45. The pass statement. Function definitions cannot be empty. But if for some reason you have a function definition with no content, put in the pass statement to avoid getting an error. So define my function and then we have place a pass. Recursion. Python also accepts function recursion, which means a defined function can call itself. Recursion is a common mathematical and programming concept. It means that a function calls itself. This has the benefit of meaning that you can loop through data to reach a result. The developer should be very careful with recursion as it can be quite easy to slip into writing a function which never terminates, or one that uses excess amounts of memory or processor power. However, when written correctly, recursion can be a very efficient and mathematically elegant approach to programming. In this example, try recursion is a function that we have defined to call itself or to recurse. We should use the k variable as the data, which decrements to by -1 every time we recurse. The recursion ends when the condition is not greater than 0. So that means when it is equal to 0. To a new developer, it can take some time to work out how exactly this works. Best way to find out is by testing and modifying it. So this is our example, try recursion. So we have a k. If k is greater than 0, result is equal to k plus try recursion k minus 1 print result. Else, so if it is not result equals 0, and then return result. So here, let's try let's take a look at 6. How did we arrive at these outputs here? So 6 is k greater than 0, yes. So result is equal to k, that's 6, plus try recursion 5, and then it will go back here. So you notice it recurses. It will first print what? That's 6 plus try recursion. So it will recurse and recurse until we produce this output, until the time that k is equal to 0. Okay, so I think you could understand this more if we try to list down the parameters. So we'll just be doing that in the classroom because it will take a long time for me to record the values of k. So, but for now, this is an example of a recursive function. So a function now is calling itself. Lambda. A lambda function is a small anonymous function. A lambda function can take any number of arguments but can only have one expression. So lambda, we have arguments, colon, and then we have the expression. The expression is executed and the result is returned. So add 10 to argument A and return the result. So lambda A, that's the argument. So A plus 10, that's the return result. So let's say if we have a print x 5, then that's 5 plus 10. So that will give us 15. So this is the value for A, the argument. So another example, can take any number of arguments. So we have here 2 arguments, A and B, and it will return the product of A and B. So if we print, so that's equal to x. So print x 5 6. So these are A and B, and it returns the product of A and B. So this gives us 30. Summarize argument A, B, and C and return the result. So lambda A, B, C colon A plus B plus C. So we have 3 arguments here now. So we have 5 will be A, 6 for B, 2 for C. So this will just add the 3 values. So the result will be 13. So why use lambda functions? The power of lambda is better shown when you use them as an anonymous function inside another function. Say you have a function definition that takes one argument and that argument will be multiplied with an unknown number. So let's say, for example, define my function, return lambda a times a equal a, that's the argument, so it returns a times n. So use that function definition to make a function that always doubles the number you send. So define my function n returns lambda a times n. So if we have my doubler equals my function 2, so we have here 2 and my doubler 11. So my doubler now will be the value of 11 here, and n is 2, so we have 11 times 2, so this gives us the value 22. So 11 will be the value for a, 2 is for the value of n. So again, the result will become 22. So why use lambda functions? Or use the same function definition to make a function that always triples the number you send in. So define my function n, so return lambda a times n, so n is 3, so that will triple any value you place for my tripler. So my tripler 11, so this one will always now triple your value. Okay, so using the same my function, so this time it will print 33, or the same function definition to make both functions in the same program. So we have my doubler, so we use 2 to double the value, and we use 3 to triple the value. So you print my doubler 11, print my tripler 11, so this will print 22, the other one will print 33. Okay, to show you the how we arrive at these values, so this is how it is done. So you notice that whatever be the value of k is plus the try recursion of k minus 1. So the value of k here will be, since we always subtract 1, will become 6, and then 5, 4, 3, 2, 1, 0. And that will recur, so 6 here plus then try recursion of 5, and then plus 4. So this will be it will be something like this. So we have 6, 5, 4, 3, 2, 1 for the first k. It was 6, 5, 4, 3, 2, 1 until 0, and then 5, 4, 3, 2, 1 until 0, 4, 3, 2, 1 until 0, 3, 2, 1 until 0, 2, 1 until 0, 1 until 0, and then 0. You just return the result if it is 0. So if it is 0, return the result. So this will be the first one that will be that will finish the recursion, so it will print 1. Then the next one is 3, and then we have 6, and then 10, and then 15, and then 21. So these are the result of this one. So we just added these values. That's why we have k plus, and then the result of the previous recursion. So this one, the result of the previous recursion. So this one, the result of the previous recursion, the result of previous recursion. So this is now, or these are the results of this recursion. Okay, so thank you very much.